Okay, welcome to part 2. Before we continue this or apply this with the different clues a while ago for our disjunction, conjunction, and or not, if and only if and if then, let us proceed first with the idea of argument. Then after that, we will be applying this, okay? Let's just have the idea of argument. Argument is divided into two ideas, and that will be premise and conclusion. When we say premise, actually, this is also a proposition, but a proposition that we need to prove that is true. A proposition that is true, or a statement should be true. Okay? And when you say conclusion, that will be your final verdict for the propositions, or that will be your final conclusion for the propositions. And the argument can be valid or invalid. So, valid if the statement, or in truth table, we have tautology. Tautology, if all statements are true, or all rows in our truth table are true, that is tautology. And if there is false, that will fall under fallacy. And fallacy is divided into two. The fallacy can be contradiction and contingency. When we say tautology, it means all are true. When we say contradiction, all are false. And when we say contingency, at least one false. Even if there are 15 true statements or true rows and one false, that will fall under invalid or fallacy. The argument will be invalid and not valid, not tautology. Okay, now let us have this idea of the premise and conclusion. If premise 1, let us have premise 1. If one loves calculus, then he loves math. And premise number 2, Mark loves math, or Mark loves calculus. Then for our conclusion, therefore, Mark loves math. So, premise number 1, if one loves calculus, then he loves math. And premise 2, Mark loves calculus, therefore, Mark loves math. So let us write this statement into symbolic form. Let us say that the one loves calculus is P. One loves calculus is C. And one loves math is M. Therefore, if one loves calculus, then he loves math. C, if C, then M. This will be the symbol that we are going to use. If C, then M. Premise number 2. Mark loves calculus. And that will be our premise letter C. Then, therefore, Mark loves math. Therefore, M. If we are going to write this in this form of argument symbolic form, premise 1, C implies M. Premise 2, C, conclusion, therefore, M. This is the idea for argument symbolic form. And if we are going to write this in truth table, don't forget that we have premise 1 and always premise 1 and premise 2 for the conclusion, then conclusion. So if we are going to write this in truth table, premise 1 and premise 2, then conclusion. Okay? So, allow me to write or let us prove if this argument is valid or invalid. Okay, let us find out. We have P or premise 1. What is premise 1? C implies M. And premise 2 and C, therefore M. This is how are you going to write this in table form. So, first, let us identify how many premises do we have. We have 2 premises. Therefore, the number of rows will be 2 raised to n, where n is the number of rows. N is the number of premises. And 2 is constant. Therefore, we have 2, how many premises? C and M, 2. 2 squared, we have 4. Therefore, we have C, M, we have true, true, false, false, true, false, true, false. We have 4 items. Then next, we need C implies N. C implies M. In our clue, for if and only if T implies F is equal to false, then the rest is true. Therefore, if T then F is equal to false, therefore, if T then T, that will be equal to true. T F, that will be equal to false. F T, true. F F, true. Because for if then T, if T, then F, the result will be F. Next, we already have C implies M. Let us have C implies M and C. True and C. So, true and true will always be true, then the rest will be false, right? Therefore, we have true and true, that will be true. False and true, that will be false. True and false, that will be false. And true and false, that will be false. Next, we have this idea, C implies M and C implies M. Therefore, from here and this one, true, true, that will be true because we have TF in order for us to have false. FF, that will be true. FT, that will be true. And FF, that will be true. Therefore, we can say that the final verdict or the conclusion are all true. Therefore, our conclusion, this statement is tautology or valid. Therefore, we can say that this idea is valid because the final result gave us all true. And in tautologies, this idea C implies M and C, then M, that is what you call modus ponens. So, in our third video, I'll be discussing the idea of proving, applying these tautologies. We have modus ponens, modus tollens, hypothetical syllogism, and more. Let us have another example. So this idea is valid since it gave us all true. Next, let us have the idea of premise 1. Let us change our next premises. Okay, let us say that our first premise is I pass. If I pass the final exam, I will graduate. I graduated. Therefore, I passed the exam. Okay, let us identify if this argument is valid or invalid. So, let us say that if I pass the exam, proposition 1 is letter E. And proposition 2, I will graduate, therefore letter G. Therefore, what are the symbols? If I pass the exam, then I'll graduate. So we have the symbol. I graduated. We have G. Therefore, I passed the exam. E. If we are going to write this in argument symbolic form, it will become E implies G, and G, it will give us E. So let us identify if this statement is valid or invalid. Let us again write a truth table for this. Again, in order for us to write the truth table, we have write first the first premise. E implies G. And always end second premise. Then the conclusion implies the conclusion, E. Now let us prove. Since we have here we have here two values or two premises, E and G. We have 2 squared is 4, true, false, false, and true, false, false. Next, we have E implies G. We have TT true, TF false, FT true, and FF true. Then we have E implies G and G. In order for it to be true, both should be true. True, true, true. The rest, false. This is true and this is false. Then implies. E implies G and G implies E. Therefore, this statement and this statement, we have true implies true, that will be true. F implies true, that will be true. True implies F, that will be false. And false implies false, that will be true. The argument is invalid because there is one true. If there is at least one true, that argument is what we call contingency. Okay? So I hope that you're learning. So let us have more examples. Our task is to identify if the given statements or the given ideas are valid or invalid. If valid, how do you call that? And if invalid, how do you call that? Okay? Let us have the following examples. Let us now use this for number 1, number 2, and number 3. Okay, we have P implies Q. If P implies Q, then if not P or Q, we have two premises. We have P and Q. Therefore, we'll be using 2 raised to n. That will be 2 squared. That will be 4. True, true, false, false. True, false, and true, false. Then, let us have P implies Q. P implies Q, it will give us true, false, true, and true. We have not P. Our not P is true, therefore false, false, true, and true. Then not P and Q, it will give us F, if P or Q, FT, therefore true, FF false, TT true, and TF true. Then we have the if and only if. P implies Q, if and only if, not P or Q. We will be using this and this one. True, true, true. False, false, true. True, true, true. True, true, true. Therefore, all last statements are true. It will give us tautology or valid. Okay, let us proceed with the second example. Our second example will be Q and not P or Q. We have here two variables or two premises. We have P and Q, therefore we have true, true, false, false, true, false, and true, false. We have P or Q. Let us have this, P or Q. True, 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 false, true, false, true, true, false, false, false. If we have true for or, if at least one true. Then we have here, not P or Q, it will give us false, 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 and true. Then Q and not P or Q. We have Q and not P or Q. TF, that will give us false. FF, false. TF, false. And FT, false. All last statements are false. Therefore, that will be invalid, and that is what we call contradiction. And for the last one, for the last item, we have number 3, P, Q, and R. P, Q, and R. We have P and Q implies R. There are 3 variables or 3 premises. Therefore, we have 2Q because 2 raised to number of premises, that will be 8. Therefore, P, Q, R, 8. True, 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 true. False, 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 false. Then we have true, true, false, false, true, true, false, false. And we have true, false, true, false, true, false, true, false. Let us have P and Q. True, 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 false, 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 false. Now we have P and Q implies R. This implies this. True, true. It will give us true, true, false. It will give us false. FT, true. FF, true. FT, true. FF, true. FT, true. FF, true. Therefore, there is at least one true, and this is an invalid argument. And this argument is said to be contingency. Okay, so that ends for the part 2, and for the part 3, you will be having your proving. God bless and good luck.